Today we're talking about proving two lines are parallel by our corresponding angles, our alternate interior angles, same side supplementary. Okay, so our common core standard geometry for G, CO for congruency, and we're going to do number 9. Okay, common core geometry congruence, and it's the 9th bullet, and it's basically prove theorems. Yeah, here we go. Prove theorems about lines and angles, which is exactly what we're doing. Okay. So let's take a look. Example 1. We want to show that N is parallel to P. So we want to prove that the two lines are parallel. Okay, so I want to show somehow that these two lines are parallel. So take a look at it, and I'll do a little bit of math. I think what I'll do first is I'll find out what this other angle right here is, angle FEC. And I know that, if it's straight lines, 180 degrees, so I'll just go straight to 180 minus 107, right? And if I take 180 minus 107, I do get 73. So this angle is 73. Okay, now I'm going to use one of my posits or theorems that I just got, right? So if I take a look at these two angles are the corresponding, right? So I'm going to say that they are parallel by my converse. You got to use the word converse. You can abbreviate if you want CONV, converse CAT, right? So because the corresponding angles are equal, it forces the lines to be parallel, okay? So we'll use converse corresponding angle, okay? Example 2. So we want angle 4, let's see, angle 4 is there, right? And angle 8 is there. So those are definitely going to be corresponding angles. So how do we prove? Well, let's find out what they are. So angle 4 is a 2x plus 10, and I'm going to let x equal 65. So the measure of angle 4 then is equal to 2 times 65 plus 10, which makes the measure of angle 4 equals, let's see, 130 plus 10 makes 140, right? Double check my math, but I think I'm right on that one. 2 times 65 plus 10, yep, 140. Okay, so let's find out about angle 8. So the measure of angle 8 is equal to my 3x minus 55, right? Let's put the 65 in. So the measure of angle 8 is 3 times 65 minus 55, and again I'll use my calculator. Check that out, so clear that. I'll go 140. Katie says 140. I'm gonna believe her. Yep, 140. So yeah, so if I have 140 for both, right? 140, it's the same reason, right? So I can say yes, they're parallel by converse corresponding angle theorem, okay, CAT, because those are corresponding angles, okay? Right? Okay, example 3, angle 6. Angle 6 is there, and angle 7. Now these, I really don't want these to be equal. I want these to add up to 180 because they're the same side interior. So I really want these two to add up to 180 degrees, okay? So let's go ahead and check it out. X is 10, so the measure of angle 6 is equal to 6 times 10 plus 18. 60 plus 18 is 78, right? So the measure of angle 6 is 78 degrees. And then, how about the measure of angle 7? Let's see, measure of angle 7 is 9 times 10 plus 12. 102, right? 90 plus 12 is 102. So the measure of angle 7 equals 102. So 78 plus 102 does make 180, right? If it didn't make 180, the lines would not be parallel. So I can say yes, that angle, that R is parallel to S by converse. You got to use the word converse because we're proving the opposite. Converse, in this case, it's the same side interior, okay? Pretty easy, thumbs up. Can I see? Okay, good, everybody agree? Okay, Am I going too fast? Am I good to turn the page? Okay, you got it, Emma. And Emma, you're welcome to slow me down anytime, okay? Okay. All right. Now in the back, we've got a proof, all right? So, first of all, let's mark what we know, okay? So, we know that L is parallel to M, okay? L is parallel. I like to mark my figure because it really helps me a whole lot. I don't know that R is parallel to P. I do not know. These two lines, that's what I have to prove. Okay, but L is parallel to M, okay? And then I want to prove somehow that R is parallel to P. So I know eventually I'm going to have to use some converse something or other, okay? So let's, obviously, step one, everybody, step one.
L is parallel to M.
Okay, L.
1 is congruent to angle 3, which is given.
Right, and angle 1 is congruent to angle 3. Good, given. Everybody agree with that? Nobody should miss step 1, right? And I like to mark, I've got my lines, my parallel lines marked. Let me mark 1 and 3. 1 and 3. Okay, got that. Okay. So, step 2. Let's see, 1 is equal to 2. Okay, 1 is equal to 2. I agree with that, but why is 1 equal to 2? Why is angle 1 equal to angle 2? It is. It's CAT, not converse, just CAT, because the lines are parallel, so it is by corresponding angle theorem. If the lines are parallel, corresponding angles are equal, okay? Now we're going to say 2 is congruent to 3. Well, if 1 is equal to 2 and 1 is equal to 3, if I'm as cool as Mason and Mason's as cool as Kurt, then I'm as cool as Kurt, right? So if 1 is equal to 2 and 2 is equal to 3, right? Then we know 2's got to be equal to 3 by transitive property, yes. Okay, now finally, if I take a look at 2 and 3, and I got to figure out, okay, what would be the name of those angles, those angles pairs?
The one
That makes the funny Y, right? So they're outside, the parallel lines, and one's on one side, one's on the other side. So it's the alternate exterior, right? So we're going to say that we can say R is parallel to P because these angles are equal, right? So it'd be by converse alternate exterior angle. How's that? Okay, homework. Please draw the picture, show the work, all right? And that's all I have.